Have you ever wondered why clustering is fundamental in data analysis? Clustering is a powerful tool that helps us find patterns in a sea of information. It simplifies complex data sets, enabling us to understand their structure and underlying relationships. This understanding is crucial in various fields, from marketing to genomics, as it aids in decision-making processes. By identifying similar groups within data, we can make more accurate predictions, develop strategies, and solve problems more efficiently. Now that we understand the importance of clustering, let's dive into one particular method of clustering: hierarchical clustering. So, what exactly is hierarchical clustering? Well, it's a type of clustering algorithm that organizes data into a tree-like model or hierarchy. The beauty of this model lies in its two main methods: agglomerative, which is a bottom-up approach, and divisive, which is a top-down approach. Agglomerative starts with each data point as a separate cluster and gradually merges them, while divisive begins with one big cluster and divides it down. Now that we have a basic understanding of what hierarchical clustering is, what if we explore the step-by-step process of an agglomerative hierarchical clustering? To understand hierarchical clustering, imagine a set of data points. These points could represent anything: customers, genes, or even galaxies. In agglomerative hierarchical clustering, we start by treating each data point as an individual cluster. So, if we have 10 data points, we begin with 10 clusters. Next, we calculate the distances between all clusters. This might sound complicated, but it's actually pretty straightforward. We're just trying to figure out which clusters are closest to each other. Once we have these distances, we merge the closest pair of clusters. Now, instead of 10 clusters, we have 9. One of these clusters, however, is a little bit bigger than the others because it's made up of 2 data points that were very close together. Then we do it all over again. We calculate the distances between all the clusters, including our newly merged one, and combine the 2 that are closest. This process continues, with the number of clusters decreasing each time until we're left with just one big cluster that contains all our data points. But remember, the goal isn't necessarily to end up with one cluster. Depending on our needs, we might stop when we have 3 clusters or 5 or any other number. The important thing is that we have a method for creating a hierarchy of clusters, starting from the bottom and building up. And voila! That's how agglomerative hierarchical clustering works. But how do we measure the distance between clusters? Determining the distance between clusters is crucial in hierarchical clustering, but how do we do it? The answer lies in the linkage criteria. Let's dive into it. We have 4 main types: ward, complete, average, and single. The ward method minimizes the variance of the clusters being merged, essentially looking for the smallest increase in total within cluster variance after merging. Complete linkage, on the other hand, uses the maximum distances between all observations of the 2 sets. Average linkage, as the name suggests, uses the average of the distances of each observation of the 2 sets. Lastly, single linkage uses the minimum of the distances between all observations of the 2 sets. Each method has its own strengths and weaknesses, and the choice of linkage method is often dependent on your specific data and goals. And with that, we have a solid understanding of the hierarchical clustering process and the different linkage criteria. So next time you're faced with a complex data set, you'll know exactly which clustering method to use. In summary, hierarchical clustering is a powerful tool for data analysis. It shines in its ability to generate a hierarchy of clusters, offering insights at multiple levels. We've discussed its 2 main approaches, agglomerative and divisive, and delved into the importance of the linkage criteria in determining cluster distances. Whether you choose ward, complete, average, or single, each has its unique strengths. Remember, understanding your data is the first step towards making informed decisions. Happy clustering!